This is the second lesson on numpy arrays. As you can see by the little 2 here, we will dive deeper into the numpy library, hopefully seeing why it is so important to data scientists and using many more of its features. You can see some of the things we're going to do, some sort of aggregation. We'll start talking about all of these numpy functions down here. I'll show you a couple examples. We'll walk through some of those. We'll learn how to, and I don't think this is in the Jupyter Notebook, so pay attention here. We're going to learn how to read a CSV file. You're going to need that for the k-means clustering algorithm. I want you to understand what a tensor is, that it's just a multi-dimensional NP array. So it's like having multiple files so visualize it like this, having multiple files of, or ranks of matrices, right? So you got a matrix that's standing in front of you, and maybe you have one behind it that's the same dimension, and 2 by 3, and then another 2 by 3 behind that one, and another 2 by 3 behind that one, and so on and so forth. And that can be as long as we want it as well. But that's the idea of a tensor, is you can have more or multiple matrices kind of lined up. And we're going to give you an example of I think it's a 2 by 3 by 2, but I want you to understand sort of what's going on and how to look at it in Python. The reason why we need to do that, to sort of visualize this thing, is that before we talk about broadcasting in the next video, it's sort of important to understand that. And then we'll talk about the NP, any, and all. I think they're down here in this thing, but they're very useful functions. Maybe in a while loop or something like that, you're going to need some of these NP, NEs, and alls. It just does a really quick check on an entire numpy array. And then we'll do a little bit of percentile calculations. Okay, so with that being said, let's go ahead and we'll bring this up first. So let's go ahead and start our video off here. Let me console restart the kernel real quick. So import numpy. We're gonna have this. You guys have seen this already. The random, the uniform 0, 1 numbers, and we could print those off or open them up. You can see it's just a bunch of numbers in here. It just gives me something to work with. So the first thing we'll do is a sum. So there's a couple of different ways to do it. You can use the method, is what this is called, right? Because this is the object m, and I'm doing a function off of that, and that gives me the sum of all the numbers. And so if you just went into this thing and added up all of these numbers, you could get something like that. Another way to do it is to do np.sum, right? And we'll do sum over m, and it would probably give you the same thing, and it does. You can see this 11.68. And then you can say, well, you know what? I want you to look down the axes, so different axes. So if you looked down axis 0, so think of that as looking down the rows. So I guess get yourself up and look down the rows, and that means we're going to have a column. So for every column, you're going to have a sum. So we're going to say axis is equal to 0. I hope this works. I haven't done this one. Yes. Okay. So you're looking down. So let me pull up M real quick. M. So what you're doing is you're looking down this row, right? So that's how I think about this axis. And it's very important to understand what's going on here. So you're looking down the axis, and so that means there's going to be a sum here, a sum here, a sum here, because you're looking down the row. So these are all the rows here, and I'm looking down them. If you were looking across, so in this direction, I would have a sum here, a sum. So I'd have 10 sums. So let's see what that looks like. So np.sum m comma axis equals 1. I'm going to sum up all the row. It just gives you this row, right? That one stands for this plus this plus this. And the 0.89 is that one plus that one plus that one, and so on and so forth. Okay, so let's do the same thing with np.min m comma axis equals 0. And again, I'm looking down the row, and for that row, give me the minimum. And you can see it's kind of close. 0.0325 is the winner, this guy right here. The minimum in this one's going to be this 0.04, it looks like. And then I had a really small one there, 0.009, the very first one. And then it just gives you so for every row, right, because I'm looking down the rows, for every row, give me the minimum in it. So we can do the same thing for column. We can look across the columns, np dot, I'll do max this time. So max m comma axis equals 1, F9, and you can see all it's doing now is just looking across, so it's looking this way, and it's going, okay, give me the max here. That's 0.391, and it's reporting out 0.391. It's looking across here, the maximum is 0.807, 0.807, and you can see how this is working. So that another thing that you might be interested in, instead of reporting out what the actual number is, you might be interested in the index to that particular minimum or maximum or whatever it is. So a way of doing that is maybe arg np.arg max m comma axis, I don't know, let's do 0. Let's look down the rows and find out what it is. Okay, so the number 9 here, let me print out m again just to make sure that we got what's going on here. So argmax reports out for the matrix M, looking down the rows. That's what this axis 0. So I'm looking down the rows here. I'm going to find the one that is the biggest. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So obviously that is the guy, 0.94929. And now I'm going to look down the axis 3. I'm sorry, the second one, right? That's what this one's referring to. And find me the maximum on this row. I mean, the maximum in this column. So the maximum, while I'm looking down the rows, there's 3 columns, right? So if I'm up here and I'm looking down on this matrix, I have 3 columns. I'm going to have one here that's going to be a maximum. I'm going to have one here that's going to be a maximum. So 0, 1, 2, 3. So 0.9833. And then I'm going to have one here that's going to be a maximum. So that looks like that 0, 1, 2, 3, 4, 5, 6. Whoa, that's pretty small to be, I mean, I guess that's just what happened in this particular case. So it's the 6th one, which is the one that I just highlighted there, is going to be the smallest. Now, if I wanted to look over, again, we could do np.arg, we'll do argmin this time, m comma axis equals 1. We get a whole bunch, we get 10 numbers, right? Just about like we hopefully expected. But now, the second, so 0, 1, 2, so that's the smallest. So no longer am I looking for the min, I'm looking for the small. In this case, this 0th one, so the second one, the second one here is the second row, and it's saying the 0th column is the smallest. And the 0th column in this one's the smallest, so it's smaller than those two. And so on and so forth, right? So we see what's going on here. I don't want to belabor the point, but argmin and argmax, those are pretty important ones to understand. And then maybe, I don't know, let's keep the m in there. All right, yeah, we'll print m. I'm going to print that so we can have it up there. And the last one I'll do in this sort of the arg sense is to do a sort. So I just want you to see what this looks like. So if I'm going to do an arg sort, and again, we'll look down rows this time. You can do either one. Axis is equal to 0, and check out what this one gives us. Okay, so the number 8 here says that if I'm arg sorting and I didn't do anything else to it, what it does is it says, okay, go find me the smallest and report back the index for that one. Since we're looking down on this one, I'm looking down on the rows. I'm going to have 10 numbers because this thing is 10. So 0 through 9, there should be numbers 0 through 9 here. And the 8th one, so 0, 1, 2, 3, 4, 5, 6, 7, 8 is going to be the smallest. So that's what that 8 is saying. 8 is the smallest one, and then 1 is going to be the second smallest. So 0, 1, right? You can see that it was pretty close. But the 1th one, yeah, I'm saying 1th. You know what I mean? Like it's the 1 index into this matrix. And the 0 one is going to be the 3rd smallest, right? So there's 0.13 here. So that's the 3rd smallest because it's the 3rd one in line here. And I can use 3rd because I am doing 1st, 2nd, 3rd. 6 would be the fourth, and so on and so forth, all the way to 9 being the biggest. So 936 probably, you see, it is exactly that, right? When I did an argmax of M and I looked down the rows, then I saw the 9, the one in column 1, or the first column is column 0, I guess I should say. So 0 index, the 9, 3, and 6, and that lines up with the bottom one down here because it just orders it. Unless you do something in here, you can. I think you can put ascending or descending in here somewhere. And if you don't know how to do that, you know what? We'll just look it up. We'll do help np.arg arg sort. All right, so here's a way of looking. Say you don't remember all the little commands in here. It's not that important. You can figure it out. So order equals none. So what does order do? Come down. Occur kind. You can tell it what kind. You can tell it the axis. You can tell it when this is specified. Fields come first. Index arrays sort also like sort arg sort. I guess it doesn't let you go the other way. I thought maybe if you put in increasing or decreasing, you could probably get it, but it doesn't look like it does that for you. But so you can just simply do once you have these indices, you can turn them around. It's not that hard to do that. Order. A single field which can be specified as a string. Okay. I might have to do a little bit more research. Maybe we can talk about this one next time. Sort in place sort. Okay. I'm not going to worry about that too much, but this is how you look up what the function actually does. And this is the people who created the function writes these, just like you should be writing doc strings. They wrote their doc strings and they're trying to explain to you, the user, how to use this thing. All right. Let's read in data from a file. So data equals to np dot, and it's a weird, I don't know, I'm sure it has something for somewhere, but this gen from text. No idea why. And then I have our file that I put on the website for you guys called XY data. But mine, so remember the dot brings you up a level. So I'm going up a level, and then I want to find XY data.csv, and I want to read that in. And then we'll print data. That's no good, right? So why is it no good? Because I forgot to do the delimiter equals. So what do I mean by delimiter? It's the thing that's between each one of my pieces of data, and I got to remember to tell them that it's a comma. And if you do that, you get this. And there's a problem with this one in the fact that there was a header on this thing. So it probably said something about X and Y. And if you remember, numpy arrays are not ones that you can mix in strings and with numbers. So that's why it gave you this not a number, NaN. So I don't remember how to do this one. Again, let's see, help np dot gen from text on. And I believe there's a way, hopefully I'm not proved wrong again, that there's a way that you can skip. Oh, there it is, skip header. So I'm going to skip header. I'm just going to copy paste it, Control C. I'm going to copy it in here. I mean, we could get rid of it just by popping it out or doing something different, but I just want to actually do it the right way. Bring it in, print it, and we get what? We get what? Hopefully no nans. Okay, so I got a good set of data here that's in a numpy array, and it's ready to rock and roll. All right, that's what this help thing can do. It can tell you sort of how to do things and help you out in different instances. Okay, so that's how you're going to do that. There's just an example of one. It's not that big a deal. If you get a header, just skip it and just grab the data. If you want the header, you can always go back and just do a regular old, read the text in and grab that information as well. All right, so remember what we talked about before. I kind of want you guys to understand what it means to be a tensor. or how to sort of visualize and conceptualize this idea of a tensor, understanding that it's sort of a bunch of matrices stacked on top of each other. So what I'm going to do here in a second, and these numbers are going to be a little different because it's a random. I'm filling those with random numbers. The back number, anyway, the red numbers there are the numbers that are behind this first matrix, right? So the black numbers, -5, 3, 1, 2, 6, 9, that is the first matrix. And then I'm going to create one that has a tensor that has another matrix behind that one, and that is represented by the 10, 35, 28, 5, 62, and 5. And if I moved this around, you would see that that's the matrix that's sort of sitting behind this one. So the idea here is when you're thinking about the tensor and you're in Python and you're telling it, hey, I'm currently looking down axis 0. So if you were in Python, you were looking down axis 0, you would only see that until you tell it to go to the next rank. And when you went to the next rank, you would only see this one. You would only see that one, right? So that one would be the one that comes out. But the idea is that you're looking down. So that's what I want you guys to think of. So you're standing here. This is my little stick figure. And I'm looking down this axis. And I can only see this first one because the other one's behind it. So I guess that's the idea. And then if you're over here and we're looking down the one. So again, in a second here, I'm going to click on it. I'm going to bring up the one axis. But the one axis is looking down the rows. And so the same idea that we talked about before with axis was equal to 0, that was rows, but now 0 is the rank. I guess I forgot to say that. So the first number in a tensor is the rank. So axis 0 now, when you got a 1 by or a 2 by 3 by 2, axis 0, the first number references the number of ranks that you have, or the number of files. And when I say files, I'm not talking about a CSV file or something. I'm talking about a file like a ranking file. So the things that are behind, I would have 2. So in this case, this would be a 2 by 3 row by 2 columns. So this would be a 2 because it's got 2 ranks. It would be 3 rows, so a 2 by 3. I guess I could write that out. And I'll do it in green here. So it's a 2 by 3 by 2, where this is the number of ranks or matrices. This is the number of rows. This is the number of columns. Okay, just to be clear about that. So this is sort of how you read that thing, and this is how you visualize it. So if I had this 2 by 3 by 2 matrix, and I'm in Python here in a second, I'm going to click on axis 0. That means I'm looking down the 0 axis, which is the rank and file axis. So we're looking down this thing. I can see this one, and when I click on another button, this one will pop up. The one behind it will pop up. Matter of fact, let's just do that right now while we're talking about it. So here is the code that gets us there. I don't want to belabor the point here, but again, these numbers are a little bit different, but be okay with that. And I'm going to pull up C, and we're looking down. So over here, you can pick 0, 1, or 2 axis. I'm going to start at 0. So we're looking down the 0 axis. We're looking the rank and file. So this is what you would expect probably if you're sort of thinking about this thing in terms of a matrix stacked behind another matrix. But I can now, because I have a 3 by 2 matrix in front of me, that's what this is, I can now click on this and take us to the very next one, and that would be the one that's behind it, right? So again, you're looking down that rank and file, and you can just click back and forth in between those two. Okay, let's go back over. And then when we're looking down down axis 1, that means we're looking at the rows. So in my mind, I picture, a guy standing on top of the matrix and looking down on it, and the only thing that they can see are these 4 numbers here. So -5, 3, and 10, 35. So that would be my first column. So here you can see it, -5, 3. That would be my first row, and then the 10, 35 would be my next row. Because, you're standing on top of your of your tensor and you're looking down on it, and let's see what that looks like. So let's go back over to here. Let's pick another axis. I'm going to look down. I'm going to look down axis 1, and the first thing that I see is this, which is negative 5, 3, which is what we said, and then in this case 23, 10, which is different than this one because these are random numbers. So that's sort of how you envision that, and then we can click on it and look at all of them. Though I can click through these 3 things, and it's going to be a 2x2 matrix. So I can click the next one, which will be the next group of numbers, right? So we go back to the picture, and so the next group of numbers is the ones that lie here, the columns and the ranks and files. 1, 2, 28, 5, 1, 2, and 28, 5. And then if I clicked again, on the next one, we get the next group of numbers. So it just depends on what you're looking down. So now I'm looking down this one, and so on and so forth. So here you're looking at from the side, and from the side, these would be the only numbers that you could see, right? Because these would be behind. So negative 5, 1, and 6 would be my first row. 10, 28, 62, 10, 28, 62 would be my second row. And if I clicked on that next one, this one would pop up. All right, hopefully that makes sense to you. I mean, I don't want to be too confusing or anything, and I don't think it should be. It's just another way to represent a bunch of numbers. And we're going to need this here at least next class, or next video, I should say. All right, last couple things that we want to get to was the Boolean comparisons. And so let me go ahead and hit F9 here. So I got this matrix A, and let me see what a matrix A looks like. I'm sorry, it's not a matrix A, it's a vector, right? So it's a column vector. And let's see, are there any, let's see, 95, greater than 95. You can do this, and broadcasting allows us to do this. And so broadcasting will allow us to look and see how all of these suckers, and are there any that are greater than 95? And it looks like that 2 of them are true. So one of the questions you might have is, are any of them greater than 95? Yeah, obviously it's true because we had 2 of them. And maybe another question you might have when you're doing some computation is, are all of them greater than 95? Oops. Answer to that is false, right? Because we know that there's a whole bunch of them that aren't greater than 95. Well, if you just looked at it, yeah, there's that are greater than 95. NP all are greater than, oh, there's a whole bunch. So 29 is not greater, 18 is not greater, so on and so forth, right? But I could come back and say, are all of them less than 143? Let's try that. NP dot all A is less than 143. Answer is true. So all of them. So if you just did A less than 143, F9, you'd expect every one of these to be true. So that's what NP, any, and NP all do. It literally gives you a very, very quick way of checking an entire NumPy data structure. Even if it's a 2-dimensional or a 3-dimensional or whatever it is, this thing will very quickly check whatever you sort of put into this thing. And it also gives you, what we'll talk about next time is what's called a Boolean mask. So you can go in and actually grab the things that are greater than 95 or less than 95 or whatever you're looking for. All right, so the last thing that I want to talk about is percentiles, and so I'm not too familiar with this thing, so the first thing I wanted to do was hit F9 on this. Let's see, come back up, and what it does is here, percentile A, looks like A is an array, okay, array-like input array, that's good, and then Q is the percentile, and I'm curious, oh, there it is. So it's numbers between 0 and 100. I was just worried that it'd be 0.95 or 0.7, instead of 75, they'd want 0.75. So if that's the case, then we can do np.percentile. Yes, I do have to sound out words in order to get them right. And then what I can do is say Q is equal to if I want the 75th percentile, we can do that, and it'll tell you 86.25. And then there's a smoothing technique in there, obviously, because these are all. Let me pull up just to make sure. The 75th percentile. There's 10 of these suckers, and we're going with some number between. There's probably between 90. Let's see, 1, 2, 3. Yeah, so 90 and 75. So it looks like the two numbers. We could do an argmin, arg sort, and it would tell us which two numbers that we're looking for. But I'm not too concerned with that. So np.percentile. So there's other ways you can do this. Percentile. If you're interested in a whole bunch of percentiles, you can say, you know what? Give me np dot in space. Let's let Q go between 10 and 95. I don't know, 5. Oh, no, it's too many. It's too many because we only have 10 numbers in here, right? So it's not very helpful. Let's just do len space go from 25 to 95 by 50. Not exactly what I was. Oh, what is A again? A is those 10 numbers. Oh, there's 20 numbers here. Okay, I got it. So remember remember what len space does. So if I just ran this, you can highlight these things and just run that. It gives a whole bunch of numbers in between 25 and 9. That's not really what I wanted. I meant to. So I was thinking it was that a range. I wanted just to be, let's go just 3 numbers. That's that's what I was looking for. This sort of was not what I was expecting. And then the reason being is because len space gives you 20 numbers between 25 and 95, which is just not good, at least in this case, because some of these should have been repeated. Oh, I guess it's not, because it's doing some kind of little algorithm that in between the two numbers. In this case, you get 18, 47, and 122. So again, if you just ran len space, it's just going to give you 3 numbers. And you can see it's 25, 60, 95. So this would be the 20th percentile, this would be the 60th percentile, and this would be the 95th percentile. Okay, that's all I got. Hope you guys got something out of this one. We will start doing broadcasting next time. It's a pretty important topic. It makes things very, very quick in your data analytics sort of things. The whole idea behind it is there's some C code that runs underneath the Python code, and it's very, very quick. And there's not a lot of memory allocation to it. So broadcasting is the way to go if you can think about how to do that. If you can't think of doing it, of course you're going to do it for a looper or whatever. But you always want to think of it in terms of, is there any way that I can do this using broadcasting? Okay, see you next time.